Our first speaker is the Federal Highway use and experience in in-place recycling. Mike Voth has over 28 years experience working in the highway industry, all with the Federal Highway Administration. His current position is the Pavement and Materials Discipline Leader, the Federal Highway Administration's Federal Lands Highway Division. Mike leads the staff that is responsible for the overall pavement and materials program, including the development of standard specifications for construction and materials, pavement design procedures and policies, and materials quality assurance. Mike and his staff are also responsible for conducting training, managing local studies, and technology deployment. Mike received his bachelor's degree in civil engineering from Washington University in St. Louis and received his master's degree in civil engineering from the University of Kansas. Mike lives and works in Colorado. So with that, Mr. Voth.
Thank you for that introduction. It's always enjoy coming down to these events and talking about one of my favorite topics, in-place recycling. Let's see the clicker. There we go. So my four topics today are, I'm going to give a brief introduction to federal lands for those that may not be familiar with us. I'm going to talk about our use and experience with in-place recycling, and hopefully spend most of the time talking about some recent performance data that we have. It's hot off the press. And then end with a few lessons learned. So in regards to federal lands, I'm going to read a few facts here. 20% of Americans' recreational activities take place on federal lands. Federal lands welcomes over 500 million annual visitors. 7% of all tourism dollars are spent on federal lands. Recreational activities on federal lands support over 370,000 jobs annually. So pretty big impact for the nation. And who we are essentially FHWA's road building arm. We provide design and construction services for roads within federal lands. And one thing there to note, under the vision there to be the partner of choice, we are a unique federal agency in that agencies do not have to use us. So we are a fee-for-service organization. So in a way, we're a pseudo-consultant. So we have to be able to produce and deliver in order to get paid. So that provides quite a motivation for us from a standpoint of, making sure we deliver on time, making sure we deliver on budget, and making sure we provide high-quality products. So and really, that's a testament for in-place recycling, that we use it so much, and we have those constraints, if you will. Federal lands is broken up into 3 divisions. We have, I'm from our Central Federal Lands Division out of Denver. And I'm biased, obviously. I think that's the best division. It certainly has a lot of the best national parks, if you will, a lot of really nice territory that we cover from the Midwest all the way out to Hawaii. Our Western Federal Lands office really covers kind of the Northwest. They're out of the Vancouver, Portland area. And then our Eastern Federal Lands office is in Sterling, Virginia, which is essentially a suburb of Washington, D.C. It says that we have 675 employees. That's when, if we were fully staffed, we're actually quite a bit below that. As many of you are struggling in this pretty hot market, it's tough to retain and hire staff these days. So I'm taking applications. If you like what you see up here, feel free to give me an application, or a resume, I should say. So what we do, as I mentioned earlier, we provide engineering and construction services to our client agencies. We design, deliver, and provide construction administration services. That's our primary bread and butter effort. We also do some safety studies, some transportation planning, as well as a little bit of technology deployment. We have four major funding programs. We have the Federal Lands Transportation Program, which funds roads within federal land highway agencies such as the National Park Service, Fish and Wildlife Service, Forest Service, and others. We have our Federal Lands Access Program. This is work where we partner with counties, cities, and states on roads that provide direct access to federal lands. We have our Emergency Relief Program, which these days, with the amounts of floods and hurricanes and fires, seems to be a quite growing program. And then we have our Tribal Transportation Program, which provides funding for the Native American reservations. And to give you an idea of the funding levels for these programs from the FAST Act, two of our larger programs are the Federal Lands Transportation Program, which funds about $365 million per year, and the Park Service gets the big chunk of that. We have the Federal Lands Access Program, too, which is another large program, $260 million a year. And then if you total up all the programs altogether, it's about $1.5 billion per year of funding for roads. And like I said, these are a quick sample of some of our federal land partners. So our market's quite large. We have about 1/3 of the land area of the U.S. That we serve, and obviously it's heavily weighted to the western U.S. So our settings. Our human resource department likes to coin the term, "We work where you play," and we do have that advantage of working in some really nice areas from the West Coast, you know, and in Golden Gate all the way to the East Coast, in Washington, D.C., to areas in between, Hoover Dam Access Road, and as well as there's a nice cold-in-place recycling train in Arches National Park. All right, that's just a quick little background on federal lands. Now, as far as our use and experience with in-place recycling, our current spec book, we have 4 standards that we use for in-place recycling. We have our Section 304, which is the mechanical FDR, no additive. We just add water and recompact the material. Section 305, which is FDR with cement. 306, FDR with asphalt, which can be emulsified or foamed. And then we have Section 310, which is cold-in-place recycling. So we have, or at least I certainly have, an advantage that a lot of my predecessors did a lot of the heavy lifting for promoting, if you will, in-place recycling. Our first project was in the early 1980s, and you know, if you total that up, we have well over 40 years of experience with in-place recycling. And because of that, Federal Lands has a tremendous amount of institutional confidence in the process. So it's not, we don't have much of a sell effort, if you will. So our first in-place recycling job was in 1982 in Rocky Mountain National Park on Trail Ridge Road. And it's interesting, Trail Ridge Road is actually the highest U.S. highway in the nation. It's at over 12,000 feet. So pretty harsh environment. The typical section on this job, I believe it was 4 inches of cold-in-place recycling with a 2-inch overlay. And it's interesting, the recycling agent was actually a reclamite, kind of a rejuvenator, if you will. And this was our first job, and it lasted about 30 years. So roughly, it lasted a little bit over 30 years. So roughly about 6 or 7 years ago, we did our second in-place recycling project on this same route, and hopefully we'll get another 30 years. So really, 60 plus years, performance we're expecting on Trail Ridge Road with two recycling jobs. So the economics is quite impressive. As far as our quantities, with the National Park Service, that number is a good number. We have a pretty robust pavement management system where we track as-built information. And so over the last 10 years, we know we've done about 830 miles of in-place recycling. That includes everything FDR, CIR. Our other clients, that's an estimated number, but we estimate at least another 600 miles of in-place recycling. So you total that up, and roughly, we're doing about 140 miles per year of in-place recycling on average. And so it's by far, someone was asking me about overlays and mill and overlays, and we just don't do those very, very often at all. This slide is a little bit dated, but it kind of gives you an idea of the spread. I would say that, today the alternatives, the CIR and the FDR with stabilization might be a little bit larger, but it still is predominantly mechanical FDR, which is pulverizing and adding water is by far still our most common type of treatment. And that's mostly due to the fact that we're dealing with lower volume roads. So to sum up kind of our use and experience, the selection, we call in-place recycling our first choice, the selection of choice. We consider in-place recycling first. It's economical. It's proven to be very economical. It reduces importing of materials. We have, as I mentioned earlier, institutional confidence in performance is really high. Our management, they avoid blaming the treatment for any problems. Essentially they blame my group if there's any issues that we didn't, and rightfully so. It's not the treatment's fault if it doesn't perform properly. It's most often due to maybe poor field investigation, poor project selection, et cetera. And it helps once we've had decades of performance. Management can see that. So that's a big factor in why our management doesn't they don't pull the plug on in-place recycling because of one failure. They usually point it back to a design issue. The other thing, and it was brought up, or explained very well, I think, in Nick's presentation, about the flexibility for geometric improvements and spot corrections. So we can, oftentimes our roads, we want to, that they were designed maybe in the 40s and 50s when there was less traffic, so maybe smaller vehicles, and so you have 20 to 22 foot wide roads, and we want to get to a place where we can get 24-foot wide roads. And so it's very flexible in allowing some small geometric improvement and spot corrections. And as I mentioned earlier, management is fully bought in with in-place recycling. All right, now for the performance. So we collect data for the Park Service's pavement management system. They have a pretty robust pavement management system. We collect the data and operate their pavement management system. There's the 6 distresses that we collect: the fatigue cracking, longitudinal cracking, transverse cracking, patching, rutting, and IRI. And then those 6 condition ratings are wrapped up into an overall pavement condition rating, and it's ranked on a 0 to 100 scale with excellent, good, fair, poor. So I think it's pretty standard. It's a photo of our data collection vehicle. It has a inertial profiler up front on the bumper for collecting IRI. It's got scanning lasers mounted in the back for collecting rutting. It has high resolution video and laser enhanced video for determining the cracks, the types of cracks and the severity of the cracks. And you can see there in the lower left, the chart there is the overall pavement condition of the Park Service's network over the last 10 to 15 years. And you can see we've been trending in a good in a good direction. So. So this graph, what I had our staff do was pull all of the recycling projects that we've done, that we have in the database. And our database isn't that old. It's in the range of 10 to 15 years old. And quantify it by whether it was a cold-in-place recycling, kind of a lighter FDR treatment, if you will, or a heavier FDR treatment. Heavier ones would be those that would have a stabilizing agent. So you can see here from the trends, it's very, very good where essentially the last, over 15 years, you can see these trend lines, we're still in the good and easily into the fair category. And what we see here is that the blue and green line, our heavier treatments are performing a little bit better than the red line, which primarily represents our mechanical FDR with mechanical stabilization. If you're curious about some of these lower ones, from a performance standpoint, those are all treatments that did not have a hot mix. So those treatments had just a double chip seal. We have several parks that have large mileage, like 100 to 150 miles of roads, and some of those roads get very minimal use. And so we go in select parks, and we'll just do a double chip seal over the in-place recycling treatment. So that, and being the fact that IRI or roughness is about 40% of the weight of the overall condition, that kind of draws down the overall PCR. But from a structural standpoint, those roads are still doing quite well. So this slide kind of shows, the previous slide just was not weighted by miles. So here you can, this slide gives you an indication by miles, where the larger the bubble, the more miles that it represents. And so you can see again, too, clearly most of our miles are all doing quite well from a performance standpoint. And just so you know, too, it's not that this line is going to continue linearly on, down, so we're going to get something like 60, 70 years of performance. We don't expect that. As maybe most of you know, that the deterioration picks up with time, and even though at 15 years it's still looking pretty good, come 20, 25 years, that curve is going to likely trend down. So the next set of slides is individual projects. So we pulled data from individual projects to see how they were performing. Again, it's quite impressive. Very good performance on our in-place recycling. This job was built, I think it says 2004, if I'm reading that correctly. And then you can see these points on top here are the cycles, the collection cycles from that data collection vehicle, and all, it's all very, very, very good performance. And that's what kind of the trend is that you'll see with these slides, is that, the initial, it was in very poor condition. We came in, did our in-place recycling treatment, and then we had a very good sustained performance over, over 10 years or more. So this road is in Death Valley. Obviously, it doesn't get a lot of moisture. So the next slide, this is in Oklahoma, in eastern Oklahoma, in Chickasaw National Recreation Area, with much higher levels of rainfall, but still the same result. Really good performance over time. Cold weather up in North Dakota in Teddy Roosevelt National Park is an FDR job with cement. And as you can see in the photo, after 14 years of performance, the road is still in really good shape. Glacier Point Road here in California, in Yosemite National Park. Again, 9 years of performance, and then the road is still doing quite well. This road here is in North Shore, or it's in Lake Mead National Recreation Area, just south of Las Vegas. Again, another FDR with cement, and again, very, very good performance. And I could go on, but again, the trend was that initially, back up here. Initially, you have a very low performance, come in and do our recycling, and we have sustained, very, very good sustained performance with time. So our other clients, that performance we have is just from the Park Service. Our other clients that we work for, we don't have condition data. We just have kind of more anecdotal information. But again, the experience has been the same. So I've got a few slides from some projects here in California. Our first cold-in-place recycling job in California was back in 1988 on Ice House Road. It's just west of Lake Tahoe. The structural section there was 4 to 5 inches of cold-in-place recycling with a 2-inch overlay. We used a high-float emulsion, and traffic was 1,080 T, but high percent, 20% or so more heavy logging trucks. And so you can see from these photos here that after 22 years, the road was looking really good. After 31 years, you can start seeing some fatigue crack coming through. That was just taken a few weeks ago. And the project is slated in 2021, is slated for another in-place recycling job. So again, here's another example. You know, the road will perform well over 30 years, and then we're coming back in and doing another in-place recycling. So again, if we get another 30 years, that's 2 in-place recycling jobs, 60 years or more performance. Wentworth Springs Road is adjacent to the Ice House Road, again west of Lake Tahoe. It has quite a bit more ADT. It's kind of a commuter route. There's a lot of residences up along this route, and it also has heavy logging. The structural section here was significantly more from a thickness standpoint than the Ice House Road. The subgrade conditions we had much softer subgrade on this route. And in 2009, it was finished. And today, 10 years later, it's still, basically spotless. I was just out there again a few weeks ago, and it was hard to find any cracking whatsoever on this road. Washington Road, again up in Northern California. Here the typical section was 3 inches of CIR, 2.5 inches hot mix overlay over the top. PRS was the CII contractor for this job. This was one of our lower traffic projects, but again, similar outcome. 2009, it was constructed, and then today, 10 years later, is still performing very, very well. So some lessons learned. Similar, and I was glad to see that Nick emphasized and talked about the importance of completing an adequate field investigation with his experience in Indiana, and that is critical. That's one thing that we found is very important. That we try to let our field investigation guide our decisions. Sometimes too, we have to remember we do a lot of work in the Rocky Mountains and the Sierra Nevadas, where we have advantageous subgrade conditions, granular, non-plastic conditions. But and sometimes we forget that when we go into the plains areas of the Midwest, where there's more clay and other softer subgrades, more rainfall. And then we've gotten burned a few times where we did not properly plan for that. Another lesson that we've learned is to, most of our projects are not in near metropolitan areas, so contractors are having to mob in from a distance. So we try to keep our in-place recycling jobs to 5 miles at a minimum or greater if possible, to take advantage of that economy of scale. We also have my group. I emphasize to my group that they're well prepared to discuss the sustainability of in-place recycling, the economics of in-place recycling, our good performance with in-place recycling. So it becomes an easier sell to our clients. So it's important to be well prepared when we're putting together our recommendations. We use the BARM's recommendations frequently for our construction specs, and we try to incorporate all best practices as included there. For instance, one item that we've felt was very important is the use of a fog seal afterwards. That just has been that's just one example. Fog sealing the cold in place recycling, afterwards before you put traffic on. And then know the limitations of in-place recycling. Again, from the BARM has a lot of good examples of the limitations of in-place recycling. So my last few slides here is kind of a quick little case study, if you will, on a project in Arches National Park that was completed a couple years ago. The main line typical section was 3 inches of CAR, followed by 3 inches of hot mix. We had some side roads that had FDR treatment, 6 inches of FDR with, again, mechanical, with 3 inches of hot mix over the top. The contractor was Coughlin. The length of the project, 20 miles of CIR was completed and 8 miles of FDR. And the traffic, that's what's highlighted here, was 2,500 ADT. And this was a narrow road where people are driving slow to look at the sites. And so it was a 22-foot wide road. So that's quite, from a standpoint of having a lot of traffic, that created some issues in itself. So this park, the Arches National Park, is one park that has been becoming more and more popular. And you can see there the rise of visitation over the last few years. And the park was very concerned about this. They were essentially saying, well, how are you going to construct a road when we have 1.5 million people planning to visit the park each year? And a lot of those, a lot of that visitation is during the construction. It's not spread out 12 months. It's during the 9-10 months of the construction season. So the answer was night work. And for this job, we got a little bit out of our comfort zone. This was our first job where we did cold in place recycling at night. And some of our obvious, concerns was, well, is it going to cure out without the benefit of the sun? And then the answer was, yeah, it was not an issue. And I think part of that is you have to kind of understand the climate in Arches National Park. It's in eastern Utah. And in the summertime, at 10, 11 p.m. at night, it still can be 90, 95 degrees with very low humidity. So that was a benefit to helping it, I think, cure out. But the park, we convinced the park to put in full closures from 7 p.m. to 7 a.m. Some of the benefits of that, it allowed the visitors to still have unrestricted access to the park during the day. The park still got their money from admissions because it didn't have to be closed down. And Because we weren't having construction operations during the day, there was so worker safety was improved, and we think production for the contractor was also improved. Here's a photo of the cold recycle mat on the right with the bottom lift of the asphalt pavement on the left. Not a lot of difference there, visually. And as I mentioned earlier, in regards to fog sealing, that worked out well. So they would fog it in the early morning, right before they opened it up to traffic, and there was really no issues with raveling or having any issue with the cold recycle mat being able to carry traffic until that first lift was placed. And the project was completed in less than 10 months, and the park was very, very happy with how it turned out. And as you can see there, this is you can see quite the queue. Like I mentioned earlier, it's a very popular park, and the traffic is queuing up at the pay booth to get in. So with that, thank you for your time.
Any questions for Mr. Voth?
When's your next flap grant cycle?
For California?
Yeah.
It'll be a couple years, I believe.
Okay.
No? Yes, sir.
My name is Long, quick California Stockton. On two slides, talking about El Dorado, actually near my neighbor. Two slides talking about 20-year job and 31-year, one photo to took the last week. And the reason that I want to know, between the 20-year and 31 year, did you do any seal coat, any preventive measure to protect the investment? Is there any reason why you not do any seal coat on 20-year and 31-year two slide on the Colorado, IC house?
So we're not responsible for the maintenance on the roads after they're constructed, and so that's up to the owner agency. In this case, it would have been the local county. I don't know how robust of a preventive maintenance program there was on that Ice House Road project, if there was a lot of chip seals being done. I can speak, though, for the Park Service. We're involved heavily with the Park Service's preventive maintenance work, and we do chip seal or microsurface the roads on a 7 to 10 year cycle. Yep.
Any other questions? Any other questions? Yes, sir.
And a question on those low volume roads where you just did a double chip seal on the FDR. How often do you have to repeat that double chip? Does it wear out faster than if it was on, asphalt, or is it more of a maintenance interval?
Yes, it does. So that we're in about a 10 to 15 year interval on those. It's just a single. The second time we just usually do a single chip seal.
That's working out for you, it sounds like.
It is, yeah. And again, those are on routes where there's low visitation. They're not necessarily routes that are going to the premier sites or attractions of the park. They're secondary sites, and so it's a cost-based decision to have a little bit lower serviceability, because that does certainly affect roughness.
Right. And if you design the FDR any differently, knowing that you're going to put a double chip versus HMA on it?
We do not, no.
Any other questions? Okay, thank you, Mr. Voth. Very good.